Good morning, viewers of MathCamp321. In this video, I'm going to present a question involving the midpoint and distance formula, a question like number 6 in chapter 9.5 of our geometry textbook, Geometry for Enjoyment and Challenge. So number 6 says to find the length of the median drawn from point A. Well, if we're looking at this triangle, ABC, and we think about what the definition of a median is, it is the line segment drawn from any vertex of a triangle to the midpoint of its opposite side. So I'm going to go ahead and I'm going to draw the median from A, just eyeballing where it would go. So I'm going to start at A, and then I'm going to aim for side BC, and I want to hit it right in the middle. So let's see if I can do that, just freehanding this. And I'm going to call this point M because it's supposed to be the midpoint. So the first thing that we need to remember is the midpoint formula to figure out what the coordinates of point M are. So M is the midpoint of B and C. It's smack in the middle of B and C. So let me start by writing down the midpoint formula. Okay, so I've written down the midpoint formula. Some people think of it as the average of the x's and the average of the y's of the endpoints. But I've written the formula out in its full form if you choose to use that. So what we need to do first is add the x's together, and the x values are the first values, the 6 and the 2. And if we add them together, we get 6 plus 2 over 2. And now we'll look at the second value, which is the y value, the 9 and the 1, and we'll add them together and divide by 2. This leaves us with 8 over 2 and 10 over 2. And then, of course, these two fractions reduce to 4 and 5. So point M has coordinates 4, 5, and it's really important to label this on your diagram. Okay, so we just found that point, and my objective here in this problem is to find the length of the median. I want to figure out how long segment AM is. So to figure out how long a segment is another way of asking what is the distance between A and M. So I'm going to use the distance formula. So whenever I'm using a formula in geometry, the first thing that I like to do is write the formula out. I don't just start writing numbers down, I start by just writing the formula. And I've illustrated that for you in the use of the midpoint formula. So I'm going to do the same thing now, but for the distance formula. Now, the distance formula and the midpoint formula sometimes are confusing to students because they both contain these x sub 1's and the x sub 2's. So one thing that I tell my students when working with the distance formula, I say to the students, have a little sass when you're solving distance formula problems. Sass, that's like a little bit of an attitude, some sass. The S stands for subtraction because you're going to subtract first, and then the A stands for addition, and then the second S stands for subtraction again. So it's subtraction, addition, subtraction. Sass. Have a little sass. Okay, so essentially what we want to do first is find the difference between the x coordinates of the endpoints of the segment that we're trying to find the length of. So in that case, it's going to be points A and M. So I'll start by writing the big square root. When you're first starting doing distance point formula problems, it's sometimes helpful to identify point 1 and point 2. Okay, so the formula says x sub 2 minus x sub 1. So that's going to be 4 minus a negative 5. Now you have to remember from algebra that subtracting a negative really means to add. So instead of 4 minus negative 5, it's 4 plus 5, then squared, plus y sub 2 minus y sub 1 would be 5 minus 8, then squared. Okay, I think I can do one more line here before I've got to find more space. 4 plus 5 is 9, so now we have 9 squared. And 5 minus 8 is negative 3, so we have negative 3 squared. 9 squared is 81. Negative 3 squared is a negative 3 times a negative 3, or positive 9. The sum of 81 and 9 is 90. And then, of course, for most geometry classes, you're going to want to express your answer in simplest radical form. So let's try to see if there are any pairs of numbers that multiply to 90 whose factor contains a perfect square. And it just so happens I can think of one. 9 times 10 is another way of writing 90. And if you think about it this way, we can write down the answer 3 root 10, because the square root of 9 is 3, and the 10 you can't break down. So the distance from point A to point B is 3 root 10, or the length of the median drawn from vertex A in triangle ABC is 3 root 10. So this is an interesting problem. It's a two-step process involving first finding the midpoint and then using the distance formula. And a couple tips to remember: write down any formula first before you start plugging in numbers, and then also remember that when you're using the distance formula to have a little sass.